Hello students of class 9, welcome to my next online class. So this is the continuation video on the chapter reflection of light. So in my previous class we have come across the definition of reflection of light, that is bouncing back of light in the same medium after reflecting from a smooth or plane surface. Also we have seen whenever a light ray falls on a reflecting surface, it bounces back in the same medium, and here angle of incidence becomes equal to angle of reflection. Also the types of reflection. Reflection can be of regular reflection, it can be of irregular reflection. Regular reflection takes place when the surface is very smooth, and irregular reflection takes place when the surface is very rough, right? So in reflection, this regular reflection, when the light rays falls on a smooth surface, the reflected ray they merges in a same specific direction. That means they comes in the same specific direction. But whereas in irregular reflection, the light rays diffuse here and there. That means they don't move in a specific direction, right? So in this class we learned what is lateral inversion and what are the laws of reflection. First law of reflection says that incident ray, reflected ray and normal at a point of incidence all lie in the same plane. That means if I consider this to be a plane mirror, right? So when a light is falling here, incident light, it will get reflected in the same medium, and here if we draw a normal, so this is an incident ray, this is a reflected ray, and this is the normal, all lying in xy plane, right? So therefore incident ray at the point of incidence, reflected ray all lie in a same plane. This is the first law. Second law says that angle of incidence is equals to angle of reflection, that is sine of angle of incidence is equals to sine of angle of reflection, or generally we say that angle of incidence is equals to angle of reflection, right? Now lateral inversion. What is lateral inversion? You see, whenever you are standing in front of a mirror, when you are raising your left hand, the mirror, the image which is formed in the mirror, it shows your right hand. That means there is a left and right, this interchange of the position of object and image, right? So this is called lateral inversion, that is the left and right interchange of object and image position when placed in front of a mirror is called lateral inversion. As you can see in the diagram, you see the letter S, when it is kept in front of the mirror, it just flips itself, okay? So now to determine a image in the mirror, there are 2 rays are required from a particular point. If you see from here point A, from point A 2 rays are coming, and from point C again 2 rays are falling on the mirror. They are getting reflected, and in the other hand this image is being formed, right? So this is called lateral inversion. Characteristic of images formed by a plane mirror. So these are the 5 characteristics of an image formed by a plane mirror. The first one is erect. So when you are standing in front of a dressing table, you will find that you see yourself, right? That means your head and your foot are in the same position, that is head is in up and foot is in down. But if you find yourself to be as opposite in that mirror, then that is called inverted image, right? So but the image which we see in our plane mirror, that is erect. Next we have virtual. That means the virtual images are those images which cannot be obtained on the screen, and the images which are formed by not actual intersection of light rays. That means the light rays appears to meet, okay? So in my last class I have taught what is a real image and virtual image. So for a complete detail, you just refer my previous video, right, for real and virtual image. So here we have learned that the image formed by a plane mirror is a virtual image and it is erect. Next, of same as the object. So whatever will be the size of an object, the same will be the size of an image. So not only the size of an object and image, the distance also remains same. Like for example, if I am standing in front of a mirror, if this is a plane mirror, I am standing in front of here. So the distance between me and the mirror is 5 meter. My image will also be 5 meter behind the mirror, okay? So the distance between the object and the mirror is same as the mirror and the image, right? Next, the image is laterally inverted, as I have already told. So the left, if you are raising your left hand in front of a mirror, the mirror will show you your right hand. That means that this left and right interchange of object and image position When it is placed on in front of a plane mirror is called lateral inversion, and the object seems to be laterally inverted, and it gets to be flipped, right? Just now we have seen the letter S. So from each and every object, 2 rays just it comes out and it falls on the plane mirror, and likewise the images gets flipped, it gets changed. Okay, there is an interchange of left and right position. Like if I say if this is a mirror and this is the letter P, right? So when you see in a mirror, the object will be like this, it will get laterally inverted. Make sure the size remains same and the distance also remains same. Next topic we have the image formation in case of inclined plane mirror. So in inclined plane mirror, it has been seen that when two mirrors are kept in front of each other, the number of images are formed. Like you see in this paragraph, when you go to a barber shop, you will find a number of images of yourself. These images are formed due to multiple reflection taking place between the mirror in your front and the mirror fixed on the wall behind you. So not only in the barber shop, also we see in the jewelry shops, like multiple mirrors are being placed in the four walls. Like in the now when they place this mirror on the four walls and when they lit the room seems to be more brighter and wider. Okay, so for this reason we place the mirrors on the four walls. Now to calculate the number of images formed by this is given by n equals to 360 by theta minus 1. So what is theta here? Theta is the angle between two mirrors and n is the number of images formed. Now if we consider two mirror is at a 30 degree, right? It is at 30 degree, then what will be the number of images formed? So if theta equals to 30 degree, if we substitute in the formula 360 by theta minus 1, here if I substitute here 30 degree, then 360 by 30, that is 12, so 12 minus 1, that is 11. But in case after cancellation, that is 360 by theta, in place of theta if it is 50 degree, then we will be getting here 7.2, right? 360 by 50, 7.2 minus 1, that is 6.2. We can round it off and we can get the whole number. When the mirrors are placed in front of each other and they are parallel to each other, you see, so number of images formed is here infinite. So we will not get a single image here, large number of images we will be getting here. So infinite number of images are formed when these mirrors are placed parallel to each other, that is 0 degree, right? But when the mirrors are kept 90 degree to each other, that is M1 and M2 and M3 and M4, you see, these two mirrors are perpendicular to each other, so the images formed here, it can be seen that three images can be formed, right? So one image you can form at O, one is at I1 and one is at I2. So when you see, three images will be formed. So let's see by this formula, like here in this case, if I place in place of theta, if I place a 90 degree, so 360 by 90, that you will get 4, so 4 minus 1, 3, so 3 images will be formed. That is clear from the diagram also, 3 images are formed. Therefore this formula is correct, right? So these are the exercise questions you need to write in your exercise book, right? This is the first exercise and this is the second exercise. So for this class only this much. See you soon in my next video.